Week 13, Lesson 1. Okay, so this video is on double angle identities, and there are formulas for them that look like this. So these are sort of interchangeable, meaning if you were given something in this format, you can rewrite it in this format and it's the same thing. Down here below this blue line, all three of these, 1, 2, 3, are all interchangeable for the cosine of the double angle. The reason we do this is there's some angles that aren't necessarily on the unit circle that it's going to be almost impossible to evaluate without a calculator. So like this one, for example, 15 degrees, right, is not on the unit circle. Okay, so I can't do this without a calculator, but that's what the problem's asking me to do. So if you look back over, not like that, if you look back over here, you can see that literally what I have in this problem is a 15 here and a 15 here, which means that I actually have a 15 over here. So this problem is equal to the sine of 2 times 15, or the sine of 30, which is on the unit circle, all right? And the sine of 30 is 1/2. Okay, so let's try another one. Okay, so this is saying to solve the equation for all values from 0 to 360 degrees. Okay, now I realize that that's weird. Sometimes we're in radians, sometimes we're in degrees. Make sure you read the problem. Okay, now the first thing that should sort of jump out at you here is that this problem has two different angles in it. The first angle is 2 theta, but the other angle is just theta. Okay, and we can't do a problem that has two different angles in it. So what we're going to do instead is we're going to make a substitution here. That is the wrong thing. Here, there we go. All right, I have 3 choices. Okay, if you look back at the formulas, I have 3 choices of what sort of substitution I can make. I am going to pick the one that has sine in it. And the reason I'm picking that is because I have sine over here. So let me make that substitution, as you are seeing right here. All right, and then I'm going to distribute. I'm going to have 3 minus 6 sine squared theta minus sine of theta equals 1. All right, now this is quadratic, right? I have a sine squared and I have a regular sine, so I'm going to set it equal to 0 by moving everything to the right. So 6 sine squared theta plus sine theta minus 2 equals 0. All right, and that is factorable. Okay, I know it seems a little weird because there's signs in there. Don't let that throw you off. All right, you still can absolutely factor that. It becomes, excuse me, 2 sine theta minus 1 times 3 sine theta plus 2. So when you set this one equal to 0, sine of theta is going to equal 1/2. And when you set this one equal to 0, the sine of theta is going to equal negative 2/3. Now this one is on the unit circle. In fact, it's there a couple different places, all right? You can have your unit circle out. Look at it. Look at all the ordered pairs that you can see on that unit circle. At 30 degrees and at 150 degrees, you will find sine values. You will find y values of 1/2. Now you can look and look and look. You are not going to find this one on the unit circle. So this one you're going to have to break out your calculator. But before you do that, think about where the sine is negative. Okay? Sine is negative in quadrants 3 and quadrants 4. So when you go to do this in your calculator, if it doesn't give you an angle that's somewhere between 180 degrees and 360 degrees, then your calculator is giving you the reference angle. So I'm going to tell you what the 2 answers are, and if you can't get them, please ask me in Zoom or ask me in person if you're an in-person person. But the answers are 221.8 and 318.2. Okay, so here I have two different angles given. You can see they are A and B, and up in the description there's some description about the fact that A is obtuse and B is acute. So let me see if I can draw this for you. A is obtuse. So this is A, but we are going to use the reference angle and just call this A prime. And if the sine of that is 4/5, that's the opposite side over the hypotenuse. And because we are in the second quadrant, this side will have to be negative. All right, now B is acute. So I'm going to draw B over here, and I'm going to use a different color. Cosine is adjacent over hypotenuse. And if you solve this right triangle, you'll find that this missing side is 15. Okay, so now we want the sine of angle A plus angle B. There's a formula for this, okay? And it's not on these particular notes. You're gonna have to look back. All right, somewhere in your notes prior, you have the sine of a sum, which is going to be the sine of A times the cosine of B plus the cosine of A times the sine of B, right? There are 4 different ratios that I need to plug in here. Okay, first one is 4/5. That was given. All right, cosine of B is 8/17. That was also given, right? They're right here. Now the cosine of A you're going to have to use based on the picture that you drew, and it's -3/5. Now can you see if you forgot that negative? This whole problem is screwed at this point. Okay, really important that you watch the signs based on the quadrants. All right, and then the sine of B, this is 15/17. All right, and if you put all of this in your calculator or you do it by hand, you will end up with -13/85. All right, and then this last one, this one says prove. Okay, just a reminder, that means you're allowed to work with one side but not the other. Okay, I definitely am going to be working with the left because that looks much more complicated. And all I have to do is continue working with it until I can get it to equal the tangent of A. All right, so I have formulas for the sine of the double angle and the cosine of the double angle. Now on the sine, I don't have a choice. So let me just fill that in. But on the bottom, I do have some choices. It may take you a couple times. All right, you may not guess right on the first try. I am going to pick 2 cosine squared A minus 1. All right, so now this positive, let me highlight them. This +1 and this -1 will cancel each other out. Okay, they're gone. Gone, 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 gone. Now I can do some more canceling. That 2 cancels with that 2. This cosine cancels with one of these cosines. And then the sine of A divided by the cosine of A is, voila, tangent of A.